Hi guys, let's start the next video. We are basically on exercise 7b of the chapter ratio and proportion. But before we start, let's quickly revise what all we've done. So we've talked about four non-zero terms are in ratio, or rather are in proportion if A upon B is equal to C upon D. Basically A is to B is equal to C is to D. This is written in the fraction form. A is to B is equal to C is to D. A and D are the extremes, B and C are the means. And when I write it in the in the fraction form, when I cross multiply, I will get A into D is equal to B into C, also known as product of extremes is equal to product of means. Next, we talked about continued proportion, where three non-zero terms are said to be in proportion, which is A is to B is to C, if A upon B is equal to B upon C. B is the mean proportional, which means if I cross multiply, we get AC is equal to B square. And then we use the K method for solving some questions. Now let's go ahead and look at the remaining questions of exercise 7b. So question number 10, that's the first question that we solved. So question number 10 says, if Q is the mean proportional between P and R. So P is to Q is to R, which means P upon Q is equal to Q upon R. What this also means is Q square is equal to PR. That's what's given. Good. Show that PQR multiplied with P plus Q plus R cube is equal to this. Okay. Again, let me remind you, three approved methods of solving left hand side is equal to right hand side. First one, work with left hand side, solve it and make it equal to right hand side. Method 2, which is approved, is work with right hand side, solve it and make it equal to left hand side. Method 3, which is work with left hand side, solve it and make it equal to, let's say, a number x. Similarly, solve right hand side and make it equal to the same number x. Since these two are equal, then left hand side and right hand side are equal. Any method which involves any operation of taking left hand side to right hand side or cross multiplying is not allowed by the board. So let's look at question number 10. So it says Q square is equal to PR. Okay, Q square is equal to PR. Let's start working with the left hand side. So my left hand side is PQR, P plus Q plus R to the power 3, which means instead of PR, I can write Q square. So this is Q square into Q multiplied with P plus Q plus R to the power 3, since PR is equal to Q square. Next, what we have is Q to the power 3, P plus Q plus R to the power 3, which means Q, P plus Q plus R whole to the power 3. Yes, I have taken both of them have the same power, which means I can write it as Q multiplied with P plus Q plus R to the power 3. Let's this is 0.6, sorry, not 5. Let's look at the next step. So let's multiply them within the bracket. So that would be PQ plus Q square plus QR raised to the power 3. Now I know Q square is equal to PR, which means PQ plus PR plus QR raised to the power 3. Reason, since Q square is equal to PR. And this is equal to a right hand side. That's exactly what they wanted us to do. PQ plus QR plus PR to the power 3. Hence proved. Done. Like I said, usually you would end up doing your question which is mean proportion, which is continued proportion, using the K method. So let me show you the same question using K method as well. I will have to erase this on this page and I will solve this again using the K method. So this time we are using the K method, method 2. So step 1, P by Q is equal to Q by R is equal to K. Let it be equal to K. Next step, what this gives me is, therefore P is equal to QK, Q is equal to RK, and if I put Q is equal to RK, I get P is equal to RK square. Now let's substitute these values in left hand side. So left hand side will give me P, which is RK square, multiplied with Q, which is RK, multiplied with R, which is R, multiplied with PQ plus, or rather P. P is RK square plus Q, which is RK plus R, which is R raised to the power 3. Let's see, what do I have? R, that's R cube, and K square into K cube. So I have taken care of all these elements outside. Anything common between these three? Yes, R is common between these three. So if I take R out, what I am left with is K square plus K plus 1 whole to the power 3. Yes, R I have taken out of these three terms. So this is R times K square plus K plus 1, everything to the power 3. This will be R cube, K cube, R cube, and K square plus K plus 1 to the power 3. Uh, I have taken the third power for R here, and I have taken it out of the big bracket, which means what I get is left hand side is equal to R to the power 6, K to the power 3, K square plus K plus 1 to the power 3. Yes, R to the power 6, K to the power 3, K square plus K plus 1 to the power 3. Perfect. Now let's try and work with the right hand side. So let's substitute values. Right hand side is PQ. P is RK square. Q is RK plus QR. Q is RK. R is R. P is RK square. R is R. And everything raised to the power 3. Yes, that's correct. Now let's see what all we have. This is R into R square, K square into K cube, plus R into R square, K plus R square, K square, everything to the power 3. Let's notice what is common between these three terms. R square is common and 1K is common. So let's take that R square and K out. Everything is to the power 3. If I take R square K out, what remains from the first term is K square. What remains from this term is 1. What remains from this term is K. And everything to the power 3. So this is R square K to the power 3 and K square plus K plus 1 to the power 3. This is R to the power 2 into 3. That's R to the power 6, K to the power 3 and K square plus K plus 1, and this is equal to right hand side. So let's give it a number 9 from 7 and 9, since LHS is equal to RHS, hence proved. So whichever method you like, you are welcome to use it. I just wanted to show you that the K method works for all the questions which is based on continuous proportion. Let's look at the next one. The next one that we are doing is question number 13. It says given A, B, C, D are in proportion, show that left hand side is equal to right hand side. So A upon B is equal to C upon D, let's say, is equal to K. Now what it means is A is equal to BK and C is equal to DK. Let's start working with the left hand side. So in the left hand side, I have A minus C multiplied with B square. So A is BK, C is DK multiplied with B square upon B minus D multiplied with CD. C is DK multiplied with D. Let me confirm. This is B minus D multiplied with DK into D. Let's see what we get. So between these two terms, I have K common. So if I take K out, I have B minus D multiplied with B square. In the denominator, I have B minus D multiplied with D square K. B minus D and B minus D gets cancelled. K and K gets cancelled, which means left hand side is equal to B square upon d square. Good, let's look at the right hand side. We can't do much here from now. Let's look at the right hand side. So right hand side is a square, which means a is bk. So this is bk the whole square minus b square minus ab, which is bk multiplied with b. Yes, that's correct. Divided by c square. C square is dk the whole square minus d square minus cd. C is dk multiplied with d. That gives us b square k square minus b square minus b square k. In the denominator, I have d square k square minus d square minus d square k. I notice b square is common in all elements in the numerator, so I take b square common. What I get is k square minus 1 minus k. K square minus 1 minus k. In the denominator, I have d square common in all three terms. So if I take d square common, what remains is k square minus 1 minus k. This and this gets cancelled from the numerator and denominator, which means a right hand side is equal to b square upon d square. So from this was from number 5 and number 9, we have left hand side is equal to right hand side is equal to b square upon d square, hence proved. So that what they wanted us to do, we've been able to prove that left hand side and right hand side are equal. Good, let's look at the next question. The next question that we do is question number 14. It says find two numbers such that the mean proportional between them is 12. Okay, so let the numbers be x and y. So the mean proportion between them, which means x is to 12 is to y, which means x upon 12 is equal to 12 upon y, which means 12 square is equal to xy, which is equal to 144. So xy is equal to 144. Next, and the third proportional to them is 96, which means x is to y is to 96, which means y square is equal to x into 96. Right, y square is equal to x into 96. So we have two equations. Let's see if we can replace one in another and see what we get. Let's call it equation 1. Let's call it equation 2. So y square is equal to 96x and xy is equal to 144. So point number 7, from 1 we will get x is equal to 144 upon y. Right, that's correct. X is equal to 144 upon y. So put x is equal to 144 upon y in equation number 2 and let's see what we get. Y square is equal to 144 upon y into 96. Yes, that's correct, which means y cube is equal to 144 into 96, which means y is equal to third root of 144 into 96. Let's try and factorize and see what we get. So I already know that 144 is 12 into 12. We are looking at the third root, right? And 96 can be written as 12 into 8. So out of these 12, 3 12s, 112 comes out, and we are looking at third root of 8. Third root of 8 is 2. So this is 12 into 2. Therefore, y is equal to 24. So we've been able to get the value of y. Let's put it in the first equation. So put y is equal to 24 in 1 and we get x is equal to 144 upon 24, which is 6. Therefore, x is equal to 6. So find the two numbers. Therefore, the numbers are 6 and 24. Perfect. Let's look at the next one. The next one that we are doing is question number 16. Question number 16 says, If P upon Q, if P is to Q is equal to RS to S, show that MP plus NQ upon Q. Okay, so what's to prove that? MP plus NQ upon Q is equal to MR plus NS upon S. And what's given is P upon Q is equal to R upon S. I noticed that we need MP and MR, which means multiply both sides by M, which means MP upon Q would be equal to MR upon S. What we've done is multiplied both sides by M. Next, we need a N as well. So let's add an N. So add N to both sides. Add N to both sides, because we are allowed to add in an equation, we are allowed to do the same operation to both sides of the equation, which means what we get is MP upon Q plus N is equal to MR upon S plus N. Let's take the LCM. We get MP plus NQ upon Q is equal to MR plus NS upon S. That's exactly what they wanted us to prove. So hence proved. Done. Let's look at the last question of this exercise that I do with you, which is question number 17. I have marked some homework questions here, 8, 9, 12 and 15. Perfect. Let's look at this question. This says P plus R is equal to MQ and 1 by Q plus 1 by S is equal to M by R. We need to prove that P, Q, R, S are in proportion. So 1 by Q plus 1 by S is equal to M upon R. Let's take the LCM and add. When we add, we get S plus Q upon SQ is equal to M upon R. Let's take Q on this side. So what we get is S plus Q upon S is equal to MQ upon R. I did this because I realized MQ is given equal to P plus R. So what we get is S plus Q upon S is equal to P plus R upon R, since MQ is equal to P plus R. That's given. So now that we do this, let's see what we get from here. Let's divide both sides. So this becomes 1 plus Q upon S is equal to P upon R plus 1. 1 and 1 gets cancelled. So we have Q upon S is equal to P upon R. Let's bring this here, basically cross multiply, which means R upon S is equal to P upon Q. That's exactly the same thing, which means P is to Q is equal to R is to S. That's exactly what they wanted us to prove. So hence proved. Perfect. That brings me to an end of this video. If you have any questions or queries, feel free to write to me. Thank you so much. Take care. Be safe. Bye-bye.